Astronomy is a science which is as old as humanity itself. From our prehistoric ancestors who recognized patterns in the starlights, to our modern-day space telescopes and space stations, a lot of progress has been made. Man has traveled to space. We have walked on the moon. And right now, as I'm talking to you, there are astronauts living and working up there in the International Space Station. So why are we so fascinated by space? What are the answers that we're trying to look for? And who are these people who are contributing to a better understanding of the universe, working from right here in Mauritius? These are some of the things that we shall explore in today's program. So sit back and enjoy this wonderful journey into space exploration. Since the dawn of civilization, man has looked for patterns in the starlight. Ancient civilizations like the Chinese and the Babylonians were able to link these patterns to changing seasons on Earth, a skill that was crucial to their survival. Iconic monuments like Stonehenge and the pyramids of Chichen Itza were built in accordance to the patterns in the starlight, and they also map out the movement of the Earth around the Sun, allowing the prediction of floods and eclipses. During the 15th and the 16th century, we've had several scientists like Copernicus, Kepler, and Galilei, who can be called the fathers of modern astronomy. Galilei being the first one to observe other planets for a telescope. The 1960s has been marked by what we call the space race, leading to the first man ever traveling into outer space and landing a man on the moon for the very first time, 50 years ago. Let us hear from Mr. Akbar of the Mauritius Astronomical Society, who's going to tell us about that era and what it entailed to land a man on the moon for the first time.
I think we have to put that era in the context of a post-Second World War period. And essentially, the Second World War showed something very important, that men could basically try to attack another country through rockets. And that literally scared those big countries. First time in human history, there were machines which could travel thousands of kilometers from one place to another without the enemy being in the same line of sight. This rocket could travel halfway or a third of the way across the world. This fortunately did not go to the extent of going further wars, but went into peaceful space exploration. Fortunately, the scientists took over, and then we realized that we could do that to explore and to see what is out there. Russians were there first, and they came in with the first men in space, Gagarin, and then they also came in with the first machines on the moon, which went there to take pictures of the moon and land on the moon. And then the US followed suit immediately afterwards and did not want to be left behind. And the US successfully came in with the first people coming in to land on the moon in the late 60s. But what is most important is not the fact that we landed on the moon in the late 60s in 1969, 50 years ago, but the journey that came to it. There have been 6 successful manned landings. There has been 7 to the moon, but infamously Apollo 13 was one of them. And as we all know from movies and from the media, that this one was not successful. But the first manned landing was in 1969. And in fact, within 3 to 4 years, they had done 6 of them, with the last one in 1972. And 12 people have successfully walked on the moon. There were more than that. There were 6 times 3, that is 18 of them, but there always had to be one who is in his taxi around the moon, waiting there, monitoring, and very importantly, being able to welcome them back while orbiting the moon in his taxi. They did scientific experiments there. They brought moon rocks back. And then they left machines on the moon, they left reflectors on the moon, which are still being used. And they left machines on the moon to measure what we call moonquakes instead of earthquakes. And all this has tremendously helped us to understand the evolution of the solar system. So essentially that material which was there billions of years ago, it's still pristine there. So it's understanding not very far from the Earth. We didn't have to travel very far to get these materials which were there, which are materials which very much are from the origins of the solar system. So it's a lot of science, and hopefully mankind will be able to continue that science by sending more people to the moon in the future. We have been able to go to the moon many more times by sending machines to the moon instead of people. We have been able to go to the other planets. We have been able to go to the most remote of some of these remote bodies, Pluto, a minor planet very far away, relatively recently. So I think there's lots of exploration which is out there, and that the machines can do it very well. But there's nothing which replaces the human mind, and nothing that replaces the human body, the human presence. And so it is very important to continue to see what we can do next in terms of human presence. And many developed countries are now working towards sending people to the moon, and the next mission is the Orion spacecraft, and also the Artemis project, which is planning about sending a first women to the moon in 2022 to 2024. So these are exciting times not just in terms of science, but exciting times in terms of economic imperatives. We have to realize that we are on Earth. The Earth is the cradle of humankind, but man does not stay in a cradle all the time. And our resources are getting limited. We are currently in a stage of industrial development where we need more and more resources. So we need to know what's out there in terms of what resources we need to use. We are using sustainable technologies, definitely, but these are only delaying the time where our resources will be depleted. So we need to travel out there, we need to see what is out there. People have to go out there in space and on the other planets, maybe hopefully into other solar systems and other suns one day in the furthest of dreams, but we have to dream sometimes. And sometimes being able to go there, discover new resources to make humanity develop in peace, hopefully. We are also, incidentally, celebrating our 50 years of existence. It started as a very modest club, a science club, astronomy club in a school at the Collège du Saint-Esprit in Quatre-Bornes. And then now we are a national association since the past 20 years. So our activities is basically that of an association of regrouping people who have an interest in the sky, in stargazing, which is free out there, which is very nice from Mauritius, provided there is no light pollution, which is a growing problem. But we are here to encourage people to be there and to understand what is out there, and also to share that. And some of our activities have always been including whenever there are eclipses, whenever there are meteor showers, whenever there are transits, and tell people, look, there's something happening out there. Please come and join us freely. We do it very freely, sometimes at the Collège Saint-Esprit where our seat is, sometimes on a beach, and tell people, look, it's fun, it's science, it's free, it's enjoyable, it's nature in action, and be also as excited as us. And we see that it's something which helps sometimes to trigger a lifelong interest in the sciences and make this young child who is watching the moon through a telescope for the first time become a kind of advocate for science for his lifetime. There's so much to read and so much to see. There are so many websites which are dedicated to astronomy. One of them is, for example, the well-known APOD, Astronomy Picture of the Day, which gives wonderful images of the sky out there. And then there's the internet, and also there are so many apps which are now on their mobile phones themselves, and where they can see the sky from their fingertips. So using a mobile phone now, they can use what we call Planetaria software to immediately start this app, which shows the sky tonight. and which shows there what is happening, what planet is there tonight. Tonight there is Jupiter and there is Saturn, but where are they? The app will show them that. Also, they can use the apps. One of them is Heavens Above to show the satellites which are moving in the sky. So astronomy is not something which requires very complicated instruments. When I started astronomy, I started without any telescope, and I started basically with a sky map, which was a paper-based sky map, an atlas, like this one, a paper-based atlas. But now there is not even a need for such documents. Now they can do everything from the internet, learn from the sky, learn what are the objects and the stars which are in the constellations which are visible tonight, and then from there, put it in practice, go out, watch the sky. It's free, it's more accessible than ever before, and it's something very exciting where there's a lot of science and a lot of knowledge of what is happening out there.
The Mauritius radio telescope at Brado has been capturing data from space since almost 3 decades now. Researchers and students from the University of Mauritius still make use of these facilities to get a better understanding of space as seen from the southern hemisphere. Dr. Nalini Iralal Isor, one of the pioneers of the Mauritius radio telescope, explains to us about the functions of the Brado station and its future.
We are right now in the Brado forest. This is state land, actually. Some 30 years ago, part of that forest was cleared along a 2 by 1 kilometer extent to build the Indo-Mauritian Mauritius radio telescope. That was a very ambitious project for that time. The purpose of this was to observe the southern sky at 150 megahertz to complement what Cambridge had already done for the northern hemisphere sky. To build it itself, it took painstaking work for many people for about 5 years. Not just the civil works, but all the technical work. And for that time, it was state-of-the-art technology. Over time, what has happened is that we have used this facility to observe the sky. Extremely faint sources. You're looking for extremely faint signals from space. They're natural signals. They're buried in noise, and you try to make some sense out of it. So with this facility, we have looked even beyond our galaxy. We are not looking at close-by planets. Most people know about planets which are close by. We have mostly been looking at distant objects, very far from us, millions of light years from us. And this has resulted into at least 11 PhDs work, research work, internationally recognized work and publications. But over the years, the system got degraded. New technology have come up, and we are even more ambitious to look at even fainter things in the sky and looking even further back in the sky. And the Square Kilometer Array project is an international project involving all the big countries of the world who are in radio astronomy. And it's trying to look at how even the universe started. We don't know everything. You know, the more we know about the universe, the more we realize that there is a lot more to know.
Our solar system consists of 8 major planets and several minor planets orbiting around the Sun. One of these minor planets holds the name of a Mauritian astrophysicist, Dr. Somanah, who is currently the Director General of Université de Mascareignes. We have met him, and he has shared with us part of this wonderful journey that led to the naming of a minor planet after his name.
Up to the 1920s, 1930s, our knowledge of the universe depended only on visible light. So in the 1930s, there was a big revolution in astronomy. That was the construction of the first telescope outside the visible band, which was a radio telescope. And from the 1920s up to now, the community of astronomers, we have built gamma ray telescopes, X-ray telescopes, ultraviolet telescopes, infrared telescopes, millimeter telescopes and radio telescopes. So all those telescopes, besides optical telescopes, were able to see what we call the invisible universe. So from the 1930s up to 1990s, we had the construction of more radio telescopes all over the world. There is an institute in Bangalore in India called the Raman Research Institute. So they had the idea of building a radio telescope in Mauritius using a radio frequency which has never been used for the southern sky. So their aim was to make a radio map of the southern sky at 150 megahertz, which has never been done before. There were two colleagues and myself, Dr. Nalini Isar, who is at the University of Mauritius right now, and Dr. Kumar Gulab, who is now an American working for the biggest radio telescope in the world in a state of Socorro in US. So together with a few Indian professors and a few engineers, we designed the radio telescope. We even built it with our hands. So Nalini, Kumar and myself, we are basically physicists. We became what we call self-trained, self-made engineers in electrical, electronic, mechanical, and even IT. So we designed and built the radio telescope, which took us 4 or 5 years. Then we had to test the antennas, the field hardware, the cables, the receiver system. Professional astronomers at that time who said that we'll fail. But we were not discouraged. We worked even harder to make it a success. So it took us a few years to work on the software which will convert the data observed by the antennas of the radio telescope into radio images. So in spite of very limited computing facilities, we worked very hard to start making the first images. So basically the software is about converting around 300 to 400 gigabytes of data, which we call binary data, into radio images. So all of us realized after building the radio telescope, after building the software, that we could write a PhD using that radio telescope. So my PhD was using that radio telescope to make radio images. Now, astronomy is a very huge field. I specialize in a field called radioactive or active galactic nuclei. So there are more than 300 billions of galaxies in the universe. Today we know all the galaxies are moving away from each other. So you have a small percentage of those galaxies which emit 1 million to 100 billion times more energy than a normal galaxy like our galaxy called the Milky Way. I've been able to image many of those radio galaxies at a radio frequency of 150 megahertz. And I did some what we call astrophysical analysis of those galaxies. There are only 2 objects in the sky where we can put the name of a human being. They are either comets or minor planets. So in our solar system you have planets. You have right now 8 planets revolving around our sun. There are some planets which are smaller, like Pluto and a few more after Pluto, which are called dwarf planets. There are others which are even smaller, which we call minor planets. So the whole thing happened when the NASA decided to give an award to the MRT team for excellence in education, discovery, and research. So they were quite impressed because we had very limited means in terms of financially, in terms of human resources. We were able to achieve something which was recognized internationally. Secondly, they wanted to also name a minor planet after one of the scientists. I should say I've been lucky. One of my colleagues, Kumar Gulab, Nalini Isar's name could have been chosen. I don't know for what reasons, maybe because I was a director of the Mauritius Radio Telescope at that time. So my name was chosen for a minor planet. So basically, the NASA and the International Astronomy Union wanted to recognize the scientific achievement of the whole team. So naming the planet after me, it's not for me only, it's for the whole MRT team, what we have been able to achieve scientifically.
Mauritius has not been left behind in the modern era of space exploration. Very soon, we shall have the very first Mershon satellite launched from from the International Space Station. We have met with the people working at the Mauritius Research Council who have conceived and will monitor the first ever Mauritian space satellite.
It all started 2 years ago at the Mauritius Research and Innovation Council, when we recently set up a unit that looks at emerging technologies and emerging sectors. This unit focuses on promoting emerging technologies, innovative technologies for the socio-economic benefits of the country. When we first heard about the Cubital Program, this presented to us as an opportunity to put the Republic of Mauritius on the map in the space sector. The Cubital Program is a collaboration between the United Nations Office of Outer Space Affairs and the Japanese Aerospace Exploration Agency. It is a program to promote space activities for developing countries and enable them to have a first satellite in space. A team of engineers at the MRIC drafted a highly technical proposal for consideration for the Cubital Program in March 2018. This proposal consisted of all the detailed calculations for the satellite, regarding the orbit calculations, the power calculations, CAD design, and so on. The proposal also detailed our long-term approach for capacity building and outreach activities, data analytics, and so on. Then in July 2018, we received the great news that we were the big winner of the Cubital Program. Then we learned that JAXA is providing us a free launch and deployment of the first Mershon satellite in space. The UNUSA believes that access to space shouldn't be restricted to only the big players, but also to small countries like Mauritius, for example, and to embark in space activities and develop national capacity in the space sector. The project is at the integration phase, and it's being tested by our main collaborator, AEC Clyde in Glasgow, Scotland. So the AEC Clyde is providing us the facilities to assemble, integrate, and test the satellite. So this satellite was designed by Mauritians, and our local engineers are being involved at each stage of the development process of the satellite. In this way, this project is very important to us for the country, as we will acquire the knowledge, the skills, the technology to operate a satellite in space. The satellite is currently in integration and testing phase, and the satellite will be ready for delivery to JAXA by the end of this year. And the launch is predicted to be about mid next year, May or June. The first Mershon satellite is a 1U CubeSat. It will have on board its system an imager that will be able to capture images of Mauritius and the surrounding ocean. These data will be available on our project website, spacemauritius.com, and also available to all the local governmental institutions. Secondly, on board the satellite we'll have a communication module which we call the island-to-island communication. It will enable us to send and receive data and messages to other islands in the region. We know that Mauritius is, as a small island developing state, is vulnerable to climate change and disaster. So this particular module will enable us to test communication for emergency purposes in the event of a natural disaster.
Today we have seen how incredible advancement has been made in the domain of space exploration. Since that first day that Galilei first looked into space with his telescope, until now, a lot has been achieved. However, it seems that we are only at the dawn of the new space era. With the boundaries of space exploration opening up to different countries of the world through international cooperation, even small countries like ours. The next few decades shall certainly be very exciting for space exploration as the universe unravels even more of its mysteries to mankind.